Friends, I would like to share with you some of the important points pertaining to aerodynamics of flying aircraft. Aerodynamics in general, it is the study of forces and the resulting motion of objects moving through the air. So studying the motion of air around a moving object, it allows us to measure the forces of lift, which allows an aircraft to overcome the gravity and the drag. So everything that is moving through the air, including the aircrafts, the rockets, birds, or even a two-wheeler or a four-wheeler, it's all affected by the aerodynamics. And coming to aircraft, the four forces of flight, they are the lift, weight, thrust, and drag. So these forces make an aircraft move up and down, faster or slower. It decides the agility, maneuverability, and the performance of the aircraft. So as an aircraft moves through the air, its wings cause the changes in the speed and pressure of the oncoming airstream. These changes result in the upward force called the lift. So when moving air encounters an obstacle, a person, a tree, a wing, an aircraft, whatever it is, its path, it narrows as it flows around the object. And even so, the amount of the oncoming air at any point, at any given moment, within the airflow is the same. So for this to happen, the air must either compress or it should speed up where its flow narrows. So air can be compressed more easily than water. So when you squeeze a stream of air, two things happen. The air speeds up, and as it speeds up, its pressure goes down. So the law of conservation of mass states that mass is neither created nor destroyed, no matter what physical changes that may take place. So this means that if the area in which the air is moving narrows, the air has to speed up, or if the area widens, then it has to slow down to maintain a constant amount of air moving through the area. So this process, it results in the random motion of air molecules creating pressure. The curved upper surface of the aircraft or the wings, it constricts the flow of air more than the flatter lower surface, causing the air above the wing to speed up more than the air below. So the faster the air speeds up, the lower its pressure becomes. So its pressure becomes lower. So the faster moving air above the aircraft or above the wings, it has less pressure than the lower part, than the slower moving air below. So the higher air pressure below, it pushes the wing up and it creates lift. And the other factors affecting the lift are the size and shape of the wing, the angle at which it meets the oncoming air, the speed at which it moves through the air, even the density of the air, etc., etc. So the primary lifting surfaces that sustain the aircraft in the flight, they are the wings, and they are the airfoils attached to each side of the fuselage. There are a variety of wing sizes, forms, and designs that are utilized by different manufacturers, by different designers, and each design meets a certain purpose, a certain performance. The top, middle, or the bottom of the fuselage can all accommodate the mounting of the wings. And coming to the control surfaces, see, to manage an aircraft which moves in three different directions, with three different dimensions, we require a variety of control mechanisms and control surfaces. So each of these dimensions, it has a control surface on the fixed wing craft. And these are typically located at the extremes of the aircraft, the tail and the wings. And the vertical stabilizers under the rudder. So these are also the primary control surfaces. The vertical stabilizers, they operate on the same theory as wings. It serves as a primary control surface for the aircraft. It obviously occupies a vertical location, typically in the aircraft tail. Vertical stabilizers may come in different numbers, usually depending on the size of the aircraft. And the rudder, it's a movable component of this vertical stabilizer. This performs the same function as an aileron in the wings. Its movement corresponds to a change in the wing's angle of attack. The stabilizers, they experience different pressures depending on the movement of this rudder. And coming to the horizontal stabilizers and the elevators, they are the primary control surfaces of an aircraft, and it's also known as the horizontal stabilizer. It performs the same function as that of a wing, adding a second point of lift along the fuselage to stabilize the aircraft. So its purpose is to manage the aircraft's pitch rather than to increase the lift. That is by modifying the angle of attack of the wing. So this is made possible through the movable components known as the elevators, which function similar to an aileron, and they are managed by the wheel's longitudinal axis. See, the ailerons, moving surfaces, they are frequently located close to the tips of the wings, and the aileron serves the straightforward purpose of changing the angle of attack of that portion of the wing by moving upwards or downwards. And the ailerons, they complement one another. So if one moves, the other one will move in the opposite directions. They regulate the aircraft's roll or the x-axis movement. There are certain devices that allow the modifications of lift in addition to the speed and pitch, the angle of attack. So these have an important impact on the wing's aerodynamics, particularly the boundary layer. And what are the flaps for? The flaps, they change a wing's curvature, increasing the lift. So the aircrafts use these flaps to maintain the lift at lower speeds, particularly during takeoff and landing. And this allows an airplane, an aircraft, to make a slower landing and a shorter landing. Flaps also increase the drag, which in turn helps to slow down the aircraft and allows a steeper landing. See, the air brakes, sometimes known as the speed brakes, they are also a type of flight control surfaces. So that is applied to an aircraft to increase the drag. Air brakes are designed to increase the drag while making little changes to the lift, and this results in a higher stall speed. A canard, it is an aeronautical term for a wing configuration of a fixed wing aircraft. Additionally, canard wings, they are often used in the guided missiles and the smart bombs. The main function of canards is to enhance the air stream through the airfoil and decrease the main wing load to have better control of the aircraft or to increase the aircraft's maneuverability. So they are also used to achieve the lift, flight control and stability. See, tilting a wing up or down, it changes the wing's angle of attack to the oncoming airstream, and it affects a wing's ability to produce the lift. See, tilting the wing upward or increasing the angle of attack, in other words, it increases a lift to a point, but it decreases the airspeed. And similarly, tilting the wing downward or say decreasing the angle of attack, it decreases the lift but increases the airspeed. So if you tilt it too much, the airflow pulls away from the upper surface and the smooth flow turns turbulent. So the wing suddenly loses lift and a condition known as a stall is created. So you can re-establish a smooth airflow by tilting the wing back to a more level position. And the thrust to weight ratio is it plays a very key role. It is a key performance indicator determining the fighter jet's ability to take off. So the ratio compares, this thrust to weight ratio compares the force generated by the jet's engines, that is thrust, to its mass, means the weight. So determining how quickly it can accelerate and ascend. So a high thrust to weight ratio means the plane can accelerate rapidly, achieving takeoff speed in a shorter distance and climbing faster into the sky. So the fighter jets, they are engineered to have a high thrust to weight ratio, enabling them to execute the quick takeoffs and perform superiority in the combat situations, enhancing its agility, speed and complex maneuvers. The design and engineering of fighter jets focus on maximizing this ratio through powerful engines and lightweight materials. The afterburners, they play a pivotal role during takeoff, especially when a jet needs to get airborne quickly or carry a heavy payload. So by injecting fuel directly into the jet's exhaust, afterburners can significantly increase thrust, but it is at the cost of increased fuel consumption. So this extra boost, it is essential for achieving the necessary speed for takeoff in combat scenarios or on shorter runways. And there is what is called as the landing gear. The landing gear is located under the belly of the plane, consisting of a wheel and this strut to soften the impact with the ground, and it may be retractable into the fuselage. A tricycle type wheels are common for general aviation with one wheel at the front and two behind. See, a moving aircraft, it causes a disturbance in the air, a wave of pressure, similar to a sound wave. Just like sound waves, any object in motion, such as an aircraft, it causes a chain reaction of colliding the air molecules to spread outward in all directions at the speed of sound. So it is the wave that travels. So the air simply moves back and forth. So this wave of molecular collisions, it is called a pressure wave. And we know that sound consists of waves transmitted through the air or other substance by molecules bumping into each other. So when these sound waves, when they reach your ear, they cause your eardrums to vibrate. Then your brain decodes the vibrations into voices, music and noises. So the shock waves, they are created by an aircraft flying faster than the sound. We shall understand about the Mach number. We use the Mach numbers to describe the aircraft's speed in terms of the speed of sound. A Mach number is derived by comparing the speed of an aircraft with the speed of sound in the air. So an aircraft moving at Mach 1, it is traveling at the speed of sound. and usually less than Mach 0.8. It is subsonic. So air is flowing in such a scenario, the air is flowing slower than sound over every part of the aircraft. And in the case of transonic, about Mach 0.8 to 1.2, the air is flowing faster than the sound over some parts of the aircraft. And if it is supersonic, greater than about Mach number 1.2, air is flowing faster than sound over the entire aircraft. And if it is hypersonic, means greater than about Mach 5. So heat becomes a critical factor here. So all parts of the aircraft, they are crucial for conducting the safe flight. Pilots must make sure that all aircraft components, they are in excellent condition before embarking on their flight journey. So thank you friends, thank you very much.